Thanks, Graham. Yeah, hi guys. I'm going to be talking about OpenDataHub tonight on OpenShift. Why am I interested? Well, my background is actually in artificial intelligence. Before I became a full-time software engineer, I did a PhD in learner classifier systems and genetic algorithms. And I've been out of the mainstream AI sector for a long, long time. And a customer asked me about machine learning, specifically about OpenDataHub. And I hadn't heard about it. So I had a quick look at it and it piqued my interest. And the more I looked at it, the more excited about it I got. So basically, what it is and what it is not, it's not a complete solution out of the box. That's something to be aware of. OpenDataHub is basically a selection of data scientist tools, specifically designed to be able to allow a data scientist to do his job. But they are quite difficult tools to actually integrate and configure and set up. So one of the things we were aiming for with OpenDataHub was to produce what we call a blueprint for building AI as a service platforms. Basically, all those kind of tools that make it easy for a data scientist to work. We don't want a data scientist to have to be bothered with installing, configuring, integrating, doing all those things that got nothing to do with data science. So put very simply, it's a set of essential tools that are very loosely integrated at this point, but still incredibly powerful if you have a good use case. Now, you can't just install OpenDataHub and then go, right, fine, I'm going to play with it. You have to know what you want to do because the tools are very specialist. So what's in it? Well, it's actually, ODH is currently at 0.9.0, which got me today because there's a different installation mechanism, which took me a while to get around. But as of 0.7, it had Airflow and Argo for workflow management and engine. So that's basically building workflows of machine learning. It had Prometheus and Grafana as part of the OpenDataHub, specifically to allow you to produce metrics based on what you are doing from a perspective of data science, as opposed to the metrics provided by the pods in OpenShift. It's got JupyterHub, which I really love, for data science tools and real-time experimentation. I'll show you a quick demo of that later. It's got the Rad Analytics Spark operator. So that's a Spark operator that we generated as part of the Rad Analytics project. Rad Analytics was our first stab at producing a community open source set of machine learning tools. And what we've done is we've taken a number of those tools and they've actually become part of the OpenDataHub. There's Kafka Strimzi for distributed streaming within the data science experimentation you're doing. There's Apache Superset for data exploration and visualization. Basically, that's very similar to the old PHP MyAdmin kind of thing you got with MySQL. It allows you to put various types of data sets in there, things like Ceph buckets, databases, files, and produces some very funky visualization based on those things. And it's got Seldon for model serving. And I'll go into Seldon a little bit later when we actually get to the demonstrations. Be aware that it's projects, not products. So OpenDataHub is actually a community project. It's not a Red Hat project. We're actually producing a productized version, which is going to be a hosted version where customers can buy space on a pre-installed version of OpenDataHub. But at the moment, it's a community operator based on these projects. And each of these projects are not a product. So it's got Prometheus, Grafana, Seldon, Spark, JupyterHub, Ceph, Strimzi, Kafka, and Argo. JupyterHub and PySpark are the bits that really sell it to me. And this is where it absolutely shines, because JupyterHub is a digital workspace for data scientists. It's basically a contained workstation within the OpenShift infrastructure. So you fire up a container, you fire up what's called a workbook, and then you interact directly with it. But the nice thing about it is it's actually got extensions within it through the images that we provide under the JupyterHub itself to use PySpark. And PySpark is an extension for Python, which gives you all those abilities to do those things you used to do in Hadoop with MapReduce. What Spark is basically a distributed compute engine that runs on multiple containers. But again, I'll show you a very quick demo of that. We also use containers for models, and this is very nice. So when you start JupyterHub itself, you get to choose from a selection of pre-built base images. And they're designed specifically for different types of tasks that you want to do in the machine learning space. The demonstration I'm going to show you uses a basic Spark image, which has also got the PySpark libraries. And these images contain all the libraries you need. So if you've got Python, it'll have the PySpark library, the NumPy, and all those kind of additional ones you might need for whatever specific tool you're trying to produce. You can produce the images yourself. So if you want to run, for example, Java, one of the specific libraries, you can do that. But the advantage of this is that when you use those images, the actual libraries are set in stone and you know what version you're using. So any data analysis or data scientific activity you do is against a known set of libraries. So demo time. If I just move this out of the way a second. So what I'm going to show you is this. And this is one of the things that's actually new with the OpenDataHub 9.0. We've got basically a front page which tells you exactly which components you've installed. And what happens is when you install OpenDataHub, you actually provide a manifest, which is a KFCTL manifest, which tells it which components of DataHub to add in. So you can produce a version of OpenDataHub that only has JupyterHub, that only has Superset. It's up to you entirely. So I've configured it to install the basic ones on this. And what I've got here running is JupyterHub. JupyterHub, as I said, is a self-contained engine for actually building and running data sciences. And how it works is you actually spin up these notebooks, and the notebooks themselves contain workbooks. Each workbook is, in essence, a running container with all of its shared file space and memory. So what I've done is I've created a number of different workbooks that I'm playing with just to show you some examples. And if I jump to this one here, which is number 3, this is what the JupyterHub workbooks look like. And what's nice about this is all running on OpenShift. So all the PySpark underneath, the Spark operator, the superset for visualization, that's all running within the namespace that I'm actually running this within. So the major advantage of this when you're using it, or when data scientists are using it, is that they don't have to install all these additional tools. They don't have to configure all these additional tools. It's provided out of the box for them. So what I'm going to show you very, very quickly is a couple of very quick examples. And the first one is actually one to do to actually introspect what you're running on. So if you bear with me a second, what I've got here is I'm just going to cut and paste the code from another window. So what this is doing is I'm adding Python code to the cell. So that cell now contains a chunk of Python code as part of my workbook. What this piece of Python does is actually goes under the covers into OpenShift and deduces exactly the status of the Spark cluster I'm using, because that's invisible to me. This pre-configured as part of the image, as part of the workbook I chose. So if I physically run that, it'll take a little while to come back. It's going off, it's actually collecting the information about the pods that are running under the covers. And eventually what it will do is come back and list all the pods that it's got access to that are running Spark. And what's nice about this is I'm actually using, there it's actually done it, I'm using Spark itself to do that, which is very, very sweet. And the second one I want to show you very, very quickly, and this is a nice one, is I've got an example that shows parallelization. I got it wrong this morning. Parallelism is the best way to say it. The parallelism nature of the Spark Py stuff. And what I'm doing with this is I've actually got a little data science experiment, which I'll just copy in. And again, another cell on the same workbook. And what this is doing is it's actually running a million jobs to try and calculate pi. And it's doing it by picking random numbers between 0 and 1, adding, actually squaring both numbers, adding those numbers together. And if those numbers are less than 1, they lie within the a virtual circle within the square. And you can actually calculate pi from it. So what this is doing is it's running a million iterations of that. So if I set that going, and you can see from the code, it's se.parallelize.map.reduce. So it's actually a map reduce function I'm doing on a parallel set of Spark clusters. So if I run that, it'll take a little while, probably takes about 3 to 4 seconds to come back. So it's 3 to 4 seconds to do a million iterations. Yeah, 4 seconds roundabout. A million iterations, and pi is roughly 3.141248. What that's done is it's run parallel a million iterations of that, of the function to actually calculate it. So you can see the kind of parallelism you can have within JupyterHub. And again, this is running on top of OpenShift. I say the last thing I want to show you very quickly, because I've got to keep this short or I'll get told off, is I've written a simulator or an emulator of COVID, just to basically look at different kind of iterations of what would happen with different versions of R, different death rates and things like this. But this shows you some of the power of JupyterHub, because what I can do is this. I can paste into a cell the definitions I want to use in my iteration, in my science experiment, in my data science experiment. And if I execute that, you'll see it comes back instantly. And what I've done is I've actually predefined those variables. And what I can do now is use a data science experiment I've got. Bear with me 1 second. I'll just copy it across. And basically, it's a very, very quick piece of Python that iterates through a number of generations and applies R, applies the death rate, applies the recovery rate. But it's using the actual variables I defined in a previous cell. And the advantage of this is you can have data science experiments in their own individual cells with configuration and setup in separate cells. In fact, you can have them in separate workbooks and import them from workbooks. So it's very good for setting up sort of multiple iterations of running through iterations of the same data science experiment. So if I execute that.
Just saying, you've got five minutes left, Eve.
Cool, thank you. So what I've done is that I've actually executed that now, and it's run, it's giving me the output. So what you're seeing here is basically the concepts of being able to run data science experiments in a workbook, in a workspace, without having to set up everything in advance. I want to show you one other feature as well, which is that when you're using the actual JupyterHub, it's not just workbooks you can put in there. So I can put text files, I can put things like links to databases, things like data sets and all those kind of things. And I've got one example based on a file. So I've created a file called testfile.txt. What I did was basically I catted the contents of the README for the OpenDataHub operator into there. So that's existing in the text file within the space of the workbook, or the actual notebook itself. And what I can do within the workbooks is that I can then effectively run iterations or run data science exercises over external entities that are contained within that workbook. So I'll try running this one. Takes a little time. What this is doing is it's setting up a Spark context. So it's grabbing hold of the Spark cluster underneath. It's loading that file into memory and then processing it to get a count of all the words and symbols within that file. Again, it's very pithy, but you can see how you can actually integrate external entities. In this case, I've actually brought a file in, just put the file into their workbook itself. And that's where the actual integration with the other components within OpenDataHub comes about. Because you can use Superset to actually generate additional databases. And those databases you can then connect into the workbook using connectors within whatever images you've got. So you can use the Python database connectors to do those kind of things. So I'll say that was a very, very brief introduction to OpenDataHub. Very quickly, if I go back to the slides, I want to tell you there's some very good links, if you bear with me 1 second. So basically, if you want to know more, there's a set of links. So we'll provide these slides after, or you can go and look at the recording. Radanalytics.io has all the projects that were part of the initial version of our machine learning exercise, including a Shinko, which generated the Spark operator. It's worth looking at that. OpenDataHub.io is where OpenDataHub lives, the community version. If you go and look at it, it's a fantastic website. The front page has got this wonderful interactive graph that is just hypnotic, and you can lose hours just sitting there and staring at the damn thing. If you go to spark.apache.org, it's the homepage for Spark itself. If you go to jupyterhub.org, that's got more information on JupyterHub, including how to configure those images I told you about, where you can set up the actual frameworks you use. And then at the bottom, there's a link to an introduction blog, which talks about OpenDataHub running on OCP. It is incredibly simple to install. If you're running OpenShift 4, you can simply go to the Operator Hub, choose OpenDataHub in the actual Operator Hub, and install it. And then you can get what we call manifests from a GitHub repo that we can provide access to, which provide you with some example manifests on how to build the components within OpenDataHub. And that was pretty much it. Graham?
Brilliant. Thank you, Heath. There's one question, and it was from me. Is that a single operator for install all of the ODH components, the data hub?
Yeah, and it actually works differently to most operators, because most operators you provide a custom resource which defines how that operator works and what it actually supports. This operator is based on top of Kubeflow, and what Kubeflow allows you to do is provide a manifest which is run through a technology called Customize. So it's slightly different. You actually provide effectively a shopping list of all the components you need, and you simply add that into the namespace where the operator is living. And the operator is looking for instances of that manifest. When it sees that manifest, it installs pre-configures and runs all the stuff you need.
So do you create the manifest first? How do you inject the manifest? Quick question.
You do OC create -f. So you create a YAML file with just the manifest in it, and then you do an OC create -f.
All right. Awesome. Thank you very much, Ian.